How do we see stars that are billions of light years away? I get this question every seminar I do, I believe. There's no question there's an awful lot of stars out there. The Bible says in Nehemiah chapter 9, Thou, even Thou art Lord alone. Thou hast made the heaven and the heaven of heavens. God created all the stars, and there's an awful lot of stars out there. It's interesting, stars blow up every once in a while. They run out of fuel or whatever happens, and they implode and then explode. It's called a nova, or if it's a big one, it's called a supernova. It seems that about every 30 years a star explodes. Well, after searching the heavens, they've only found 300 supernova rings. So the question would be, if the universe is millions of years old, why aren't there more supernova rings, the remnants of these blown up stars? That indicates only a few thousand years. Of course, the Bible says God made everything 6,000 years ago, and the textbooks say it's billions of years old. I think the textbooks have a problem because there should be a lot more supernova rings. Plus, obviously, you have a problem. Stars being born should equal stars dying, or else you're going to have a real serious problem. There are plenty of stars out there, but we've never seen one star forming. We see stars blow up every 25 or 30 years. We've never proven the formation of one new star. One atheist I debated said, oh, Hovind, there's this new star forming right now in Crab Nebula and some of the different clouds out there in space. You see stars forming. No, you don't. You see spots getting brighter. You are assuming a star is forming, but actually all you're seeing is a spot getting brighter. It could be there's a dust cloud clearing and there was already a star behind it. Any fourth grader would know that. So nobody's ever proven the formation of one star. In Science magazine in '86, they said the silent embarrassment of modern astrophysics is that we do not know how even a single one of these stars managed to form. The situation is no better now. Nobody can prove any star formed by natural processes. If dust tries to get together, as it increases in density, it increases the temperature, which increases the movement, and it drives it back away. It's called Boyle's gas laws. You cannot compress dust into solid matter without creating a real serious physical science problem of overcoming the gas laws. The pressure increases, the temperature increases, which drives them out again. It's not going to happen. One professor said, oh, Hovind, we figured if 20 stars explode near each other, they'll produce enough energy to squeeze the gas and make a new star. I said, well, sir, that's just brilliant. You know, you're saying if you lose 20, you can gain 1. Man, you ought to run for Congress and help those guys borrow their way out of debt. You know, that's a dumb idea. We've never seen it happen. It's purely theoretical that 20 stars could do that, but that is a losing proposition, not gaining. There are lots of stars. The Bible says God created the stars in Genesis 1:16. He created them to be lights on the earth. Psalm 147 says He counts the number of the stars and gives names to all of them. The Bible says He layeth the beams of His chambers in the waters, who maketh the clouds His chariot, who walketh upon the wings of the wind. It is possible that Psalm 104 ties in with Psalm 148, that there is still water above the heavens. Nobody knows what's beyond the stars, if there's an end at all. But it could be that this verse and verse in Revelation where the Lord sits on many waters is talking about the fact that there was a layer of water above the earth, and there may be another layer of water beyond the stars. Don't know, just a theory, something to chew on. There's no way we can tell anyway. Okay, there's a lot of stars out there. It's been estimated that everybody on earth could own 2 trillion stars to yourself. That's a lot. Million, billion, trillion. The stars are really far away. Hubble telescope focused in on a dot. They thought they found a black spot in space about the size of a grain of sand held at arm's length. They looked at that spot for 10 days, and in that one spot there were so many stars they'd never seen before that they couldn't even count them. That's just one spot, the size of a grain of sand, new stars just discovered. There's a lot of stars. Stephen Hawking, who hates Christians and creationists, said, and won't debate me, by the way, Steve, I'll take on any time. He said, stars are so far away, they appear to us to be just pinpoints of light. He said, there's only one feature we can observe, that is the color of their light. So when you look at a star, you cannot see the size or shape of the star. All you see is what color it is. We assume that stars are like the sun, and the sun is like stars, but that is purely an assumption. We don't know that. Some people say, oh yeah, we can tell by the elements that it's burning. It gives a color characteristic, you know, the signature, you can tell the elements. You know, evolutionists never talk about this, but they are, of course, assuming that even the molecules evolved in other places just like they evolved on Earth. They're assuming the same 92 elements we have here would be the same found throughout the universe. They've never talked about that, but you have a real serious problem if you just assume that the same molecular arrangement evolved, because molecules would have to evolve too by your theory, which I think is a dumb idea. Okay. I taught high school trig for many years as one of the subjects I taught. If you want to find the distance to an object you can't possibly touch, like a star, you have to measure it with what's called parallax trigonometry. You have to know two sides and one angle, or two angles and one side, in order to calculate the distance to this unknown point, or to this unknown distance to this point, with simple sine, cosine, tangent. The problem is, Earth is only 8,000 miles in diameter, which is basically nothing compared to star distance. So to find the distance to a star, you have to get your observers further apart to make a triangle. That's, you know, a decent angle. Well, they look at the star in January, then they look at the star in June, and they get a much bigger base on their triangle. This is Earth's orbit around the Sun. Well, it's 93 million miles to the Sun, which is a long ways, but it takes light 8 minutes to get here from the Sun. It's called 1 astronomical unit. That is, the distance from the Sun to the Earth is an AU, an astronomical unit. So we are 8 light minutes from the Sun, which means the diameter of our orbit is 16 light minutes. That would be the diameter of Earth's orbit around the Sun. This diagram here shows a little yellow dot on the far left. That would represent Earth's orbit, 16 light minutes. A year has 525,000 minutes in it. That's a real skinny triangle if you did it to scale. It's like having two surveyors with, you know, telescopes 16 inches apart, looking at a dot 525,000 inches away, which is 8 1/3 miles. You set that up and draw it out on a piece of graph paper, you find you got a real skinny triangle. It works out to be an angle of 0.017 degrees at the apex. I think you can have a hard time measuring something like that. If you want to measure 100 light years, by the way, that was just to measure 1 light year. If you wanted to measure 100 light years, you'd have to move your dot 830 miles away, keeping your surveyors 16 inches apart. That's like having two guys on my roof here in Pensacola, Florida, looking at a dot in Chicago. If the guys are 16 inches apart and they're focusing on a dot in Chicago, that's a real skinny triangle, okay? Figuring 15 billion light years is clearly impossible. It just can't be done. And I don't think you can tell exactly where you were 6 months ago on opposite sides of Earth's orbit. That would be a stretch also. Okay, this textbook says parallax trigonometry can be used to measure distances less than 100 light years. I agree, much less. I think you'd have a hard time measuring 20 light years, but I'll give them 100, I'll give them 500 for the sake of the argument. The fact is you can't measure a billion. I'm not saying the stars aren't that far away, they probably are. I'm just pointing out we have no way of measuring it. We don't know how far away they are. If somebody tells you that star is, 7.9 billion light years away, just say, how did you measure it? Was it a Stanley, a Lufkin, or a Craftsman? And who held the other end of that tape measure? Because I want to meet this guy. It just can't be done. So number one, we cannot measure the distance to the stars. Number two, we don't know what light is. Is it a wave? Is it a photon? Is it a particle? It behaves sometimes like waves, sometimes like energy. Nobody knows for sure what light is. We know what it does, and we use it all the time, obviously, but nobody's ever defined what light is very clearly. So the entire principle or concept behind a black hole is the idea that light can be attracted by gravity. Well, if light can be attracted by gravity, if black holes exist, which nobody's proven that either, but then the speed of light can't be a constant. At Harvard University in '99, they slowed light down to 38 miles an hour. The next year, they slowed it down to 1 mile an hour in the year 2000. The next year, they brought it to a dead stop. They took light and absolutely stopped it. This was done at Harvard, it was done at Smithsonian, and it was done at Cambridge. And by the way, that's how science works. An experiment should be demonstratable, repeatable, testable. Evolution is none of those. Nobody's ever demonstrated or tested or proven any of it. It's all in the mind. They think it happened. It's not science. Okay. At Princeton University in the year 2000, they speeded light up to 300 times the speed of light. Why would the speed of light be an unbreakable barrier? Barry Setterfield, Australian astronomer, did a lot of work on the speed of light question. He says the speed of light has decreased. He said in the last 300 years, at least 164 measurements of the speed of light have been published, 16 different ways it was measured. He said the speed of light has apparently decreased so rapidly that experimental error cannot explain it. Here's a chart showing that the speed of light has declined in the last 150 years. About 1960, the chart seems to level off, and everybody since about 1960 has gotten the same number. If you measure the speed of light today, you're probably going to get 186,282 point something miles per second. Okay. That could be because in the late 50s and early 60s, they began using the atomic clock to measure the speed of light. And the atomic clock uses the wavelength of a cesium-133 atom, which means you're using light to measure light. You have a rubber ruler. Of course, you're not going to see it if it's declining.